June 1942. The Eastern Front. Soviet forces advancing on Stalingrad encounter a sound they've never heard before, a mechanical scream ripping through the air at 1,200 rounds per minute. Not the rhythmic thump-thump-thump of conventional machine guns, but a continuous buzzsaw of death that tears through infantry formations before soldiers can even process what's happening. Russian troops call it linoleum ripper because the sound resembles fabric tearing at impossible speed. American GIs landing in North Africa 6 months later will have their own name, Hitler's buzzsaw. The MG42 fires so fast that individual shots blur into a single sustained roar, and it doesn't just fire fast for a few seconds before overheating. It sustains this apocalyptic rate of fire for minutes at a time, longer than any machine gun in history. The German military has achieved something that every other nation's ordnance experts declared physically impossible: a machine gun that fires twice as fast as anything else on the battlefield, without melting its own barrel. Allied intelligence officers, examining captured MG42s in Tunisia, can't figure out how it works. The barrel should be glowing red and warping after 250 rounds. That's the hard limit for the American Browning Men 1919, the British Bren, the Soviet Maxim. Every heavy machine gun in service overheats at roughly the same rate, because metallurgy doesn't lie. Fire 600 rounds through a 22-inch steel barrel in 90 seconds, and physics says that barrel is done. The steel loses temper. The rifling deforms. Accuracy goes to hell, and if you keep firing, the barrel can split like an overripe tomato. But the MG42 laughs at these limitations. German machine gun teams are firing 1,500-round belts in sustained bursts that would destroy any other weapon, then immediately engaging new targets without pausing to let the barrel cool. The battlefield math becomes horrifying. A single MG42 position can put more rounds downrange in 2 minutes than an entire American rifle squad can fire in 10. The suppressive fire is so intense that Allied infantry learn to recognize the sound and immediately go to ground, because standing up when that buzz saw opens up is suicide. In August 1942, at Aberdeen Proving Ground in Maryland, American ordnance engineers receive their first intact MG42. It arrives in a wooden crate marked with Wehrmacht stamps, captured by British forces at El Alamein. The testing team includes some of the best weapons designers in the United States, men who've been building machine guns since World War I, who know every trick for managing heat and maintaining sustained fire rates. They field strip the weapon, expecting to find some revolutionary cooling system, maybe forced air channels, or a complex water jacket like the old Maxim guns used. Instead, they find elegant simplicity that makes them question everything they thought they knew about machine gun design. The barrel comes out in 5 seconds. No tools required. One gunner pulls back a simple spring-loaded catch on the right side of the receiver, rotates a locking sleeve 90 degrees, and the entire barrel assembly slides forward out of the weapon. A fresh barrel slides back in. The sleeve rotates to lock, the catch snaps shut, and the gun is ready to fire. Total time 5 seconds, maybe 7 if you're being careful. The American engineers run it through the sequence 20 times, timing each barrel change, the average 5.4 seconds. They've been working on quick-change barrel systems for the Browning M1919 for 3 years, and their best prototype requires 35 seconds with specialized tools. The Germans have achieved the same function in 1/7 the time with a mechanism so simple it has 3 moving parts. The lead engineer, Colonel Thomas Jarvis, writes in his report, "The barrel change mechanism represents a fundamental rethinking of sustained fire doctrine. While we have been attempting to build barrels that can withstand extended firing, the Germans have instead built a weapon that assumes barrels are consumable components to be swapped as needed. This philosophical shift changes everything. American doctrine says you fire in controlled bursts to manage heat. You pace your fire. You treat the barrel as a permanent component that must be protected. German doctrine says you fire as fast as you want and swap barrels when they get hot. The weapon adapts to combat reality, instead of forcing combat tactics to adapt to weapon limitations. The question becomes, who designed this system, and how did they solve problems that stumped every other nation's ordnance engineers? The answer leads back to 1934 and a small metal working shop in Oberndorf, Germany, where Mauserwerke has just received a contract from the Wehrmacht to design a new general-purpose machine gun. The German military wants something lighter than the MG34, cheaper to manufacture, and capable of higher sustained fire rates. The specifications read like fantasy: 1,100 rounds per minute, cyclic rate, reliable operation in desert sand and Russian mud, simple enough for conscripts to maintain, and capable of continuous operation limited only by ammunition supply. The chief engineer, Heinrich Vollmer, assigns the barrel problem to his most unconventional machinist, a 34-year-old named Karl Maier, who has a reputation for ignoring established practices and redesigning things from first principles. Maier's personnel file includes notes like refuses to follow standard procedures and insists on questioning design assumptions, which in the rigid German engineering culture of 1934 is not exactly a compliment. But Vollmer knows that conventional thinking isn't going to solve this problem. Every machine gun design since the Maxim has treated the barrel as a permanent fixture that must be protected and managed. Maier's assignment: throw out that assumption and start over. Maier begins with basic physics. A steel barrel absorbs approximately 30% of the heat energy from each cartridge fired. At 1,200 rounds per minute, that's 20 rounds per second, each adding thermal energy faster than the barrel can radiate it away. Do the math, and a barrel reaches critical temperature above 600 degrees Celsius, where steel loses structural integrity in about 90 seconds of sustained fire. You have three options: make the barrel thicker to absorb more heat, which adds weight, reduce the rate of fire, which defeats the purpose, or remove the hot barrel and replace it with a cool one. Previously considered impractical, Maier chooses option 3, but he understands why everyone else rejected it. Previous quick-change barrel systems failed because they introduced three critical problems. The barrel alignment had to be perfect, or accuracy suffered. The locking mechanism had to be robust, or the barrel could come loose during firing. Catastrophic failure. And the system had to be simple enough for soldiers to operate under combat stress without specialized tools or training. Solve those three problems, and you can fire indefinitely. Fail to solve any one of them, and you've built a weapon that's either inaccurate, dangerous, or too complex to be practical. Maier's first breakthrough comes from studying how breech-loading artillery maintains barrel alignment. Large guns use interrupted thread systems, rotating collars with matching threads that lock components together. Scale that down to machine gun size, and you get a mechanism that's both strong and fast to operate. His design uses a cylindrical barrel collar, with 3 locking lugs that engage matching recesses in the receiver. Rotate the barrel 90 degrees, and the lugs align with exit channels, allowing the barrel to slide forward. Rotate it back, and the lugs lock into their recesses with mechanical certainty. The system is self-aligning because the cylindrical surfaces naturally center the barrel as it slides into position. The second breakthrough solves the problem of how soldiers can actually use this. Maier designs a spring-loaded catch that holds the locking collar in place during firing, but releases with thumb pressure. A simple lever built into the receiver allows one-handed operation. Press the catch, rotate the handle, pull the barrel forward, reverse the sequence to install a fresh barrel. The entire mechanism has no removable small parts to lose, no tools required, no adjustments needed. It's mechanically locked during firing with enough strength to handle the violent recoil forces, but releases instantly when you need it to. The third breakthrough is recognizing that barrel alignment doesn't have to be perfect. It has to be consistent. Machine guns aren't precision rifles. Combat effective accuracy at 800 meters means hitting a man-sized target, not punching through a silver dollar. As long as each barrel indexes to the same position every time, The slight variations between barrels don't matter practically. Maier's testing protocol proves this empirically. He builds 5 test barrels, fires 100 rounds through each to establish a zero, then swaps barrels randomly, and measures point of impact shift. The maximum variation, 3 inches at 100 meters. For a weapon firing 1,200 rounds per minute in a cone of dispersion measured in feet, this variance is irrelevant. By spring 1937, Maier has a working prototype quick-change system. The real test comes at the Kummersdorf Proving Ground, where Wehrmacht evaluators run torture tests designed to break new weapons. They fire 12,000-round ammunition belts, changing barrels every 250 rounds. The gun keeps running. They bury it in sand, drag it through mud, freeze it overnight, and fire it at dawn. The barrel change mechanism functions every time. The cost analysis makes the design even more attractive. Manufacturing the barrel locking system adds approximately 4.5 Reichsmarks to the weapon's production cost. Training soldiers to change barrels takes 15 minutes. In exchange, the MG42 gains the ability to sustain fire rates that no other machine gun can match. The Wehrmacht adopts the MG42 in May 1942, and the first units reach combat troops in North Africa that summer. The tactical impact is immediate and devastating. July 1942, Rozhev Salient, Soviet Union. A German infantry platoon, defending a rail junction, faces a Soviet assault by a reinforced company, 120 men advancing across 400 meters of open ground. The German position includes 1 MG42, with a crew of 3, gunner, assistant gunner, and ammunition bearer, carrying 4 spare barrels. The Soviet infantry advance in waves, expecting the German machine gun to fire in short bursts to manage overheating, creating gaps in suppressive fire that allow them to bound forward between bursts. That's how every machine gun battle has worked. Instead, the MG42 opens up with continuous fire that sounds like an industrial saw cutting metal. The gunner holds the trigger down, traversing smoothly left to right, putting rounds into every meter of the killing zone. After 250 rounds, about 20 seconds of sustained fire, the barrel is glowing cherry red. The assistant gunner already has a fresh barrel out of its carrying tube. The gunner releases the barrel catch with his right thumb, while his left hand rotates the collar. The hot barrel slides forward into the assistant's gloved hands. Fresh barrel in, collar rotates back, catch locks. Total elapsed time, 6 seconds. The MG42 resumes firing before the Soviet troops can process that it stopped. Another 250-round belt, another barrel change, another 6 seconds of silence in a maelstrom of continuous fire. The German gun crew cycles through 4 barrels in 3 minutes, firing over 1,000 rounds. The Soviet assault collapses before reaching the German position. The survivors fall back, leaving 40 dead in the killing zone. The Soviet after-action report describes a new German automatic weapon of extraordinary fire rate that does not observe normal cooling requirements. Soviet infantry commanders begin warning their troops about the sound, that continuous tearing roar. That means the Germans have an MG42 position, and standard assault tactics will fail. November 1942, Kasserine Pass, Tunisia. American forces encounter MG42s for the first time during the German counteroffensive. The 168th Infantry Regiment attacks what intelligence reports as a lightly defended position, 3 German machine gun nests covering a mountain pass. The American infantry advance in textbook fashion, using terrain and suppressive fire from their own M1919 Brownings to bound forward. The German positions remain silent until the Americans close to 300 meters. Then the MG42s open up simultaneously. The fire density shocks veterans who fought in World War I. One soldier later describes it as like every machine gun in France firing at once, except it was just 3 guns. The Americans go to ground, pinned by fire so intense that raising your head draws an immediate burst. The attack stalls completely. American machine gun crews try to suppress the German positions, but the return fire demonstrates the MG42's tactical advantage. The Browning Men 1919 fires 450 rounds per minute and must fire in controlled bursts to prevent overheating. The MG42 fires 1,200 rounds per minute and changes barrels in seconds. It's not a fair fight. The American attack fails with 54 casualties. The 3 German machine gun crews, each consisting of 3 men with 1 MG42, have held off an infantry company of 180 soldiers. The guns fired approximately 8,000 rounds combined, cycling through 32 barrel changes without a single mechanical failure. By early 1943, Allied forces developed tactical doctrines specifically for dealing with MG42 positions. The British 8th Army's Field Manual includes a section titled Countering High Rate of Fire Enemy Machine Guns that essentially says, use artillery, use mortars, use tanks, use anything except infantry assault, because walking into MG42 fire is suicide. The psychological impact proves as significant as the tactical one. Soldiers learn to recognize that distinctive tearing sound, and it triggers immediate fear responses. American infantry training in 1943 includes recordings of MG42 fire so troops don't freeze up when they hear it in combat. The sound becomes synonymous with German defensive positions. If you hear the buzzsaw, you've found the hard point. German tactical doctrine evolves to maximize the MG42's strengths. The weapon becomes the centerpiece of defensive positions, with riflemen positioned to protect the machine gun rather than the other way around. MG42 crews carry 6 spare barrels as standard equipment, giving them the ability to fire 1,500 rounds sustained before running out of fresh barrels. Ammunition expenditure rates skyrocket. A single MG42 position might fire more rounds in one engagement than an entire Wehrmacht infantry squad fired in a week during World War I. The barrel change system proves so reliable that it becomes the weapon's most praised feature. German training manuals emphasize that the MG42's effectiveness depends entirely on the crew's ability to maintain continuous fire through rapid barrel changes. Crews drill until they can change barrels blindfolded because night actions and smoke-filled bunkers mean you can't always see what you're doing. One captured German machine gun manual includes barrel change timing standards. Acceptable, 8 seconds. Standard, 6 seconds. Expert, 4 seconds. Elite units compete for fastest times, with some crews achieving 3-second changes through obsessive practice. The maintenance requirements prove minimal, unlike complex mechanisms that need constant adjustment. Maier's barrel system is self-aligning and has enough built-in tolerance that it works even when dirty. German crews in Russia report firing the weapon in -40 cause temperatures without lubrication. Frozen oil causes malfunctions, and the barrel change mechanism still functions. Desert campaigns in North Africa demonstrate the opposite extreme. The weapon operates in 50 degrees heat and sandstorms that jam most mechanical systems. The few failures that occur are instructive. When barrels do get stuck, it's almost always because crews waited too long to change them, firing beyond the recommended 250-round limit until the barrel expanded enough to bind in the receiver. The solution: follow the drill. The weapon tells you when it's time to change barrels. When you feel the rate of fire slowing slightly from heat expansion, that's your warning. Change it immediately, and you'll never have problems. By 1944, the Wehrmacht has produced over 400,000 MG42s, and the weapon's reputation has spread to every front. Allied intelligence reports describe it as the most effective infantry weapon in the German arsenal, and note that capturing an MG42 position requires either overwhelming firepower or accepting very high casualties. American weapons designers at Springfield Armory begin working on their own quick-change barrel system, but they're trying to retrofit it onto the existing M1919 design rather than building from scratch like Maier did. The result is a compromise that never matches the MG42's elegance. The M1919A6 gets a quick-change barrel, but it requires a specialized tool, takes 25 seconds to change, and adds weight to an already heavy weapon. The British examine captured MG42s and reverse-engineer the barrel system for their planned Bren gun replacement, but the war ends before they complete development. The design lessons from Maier's work eventually influenced the British L7 GPMG and the American M60, both of which feature quick-change barrels, though neither matches the MG42's 5-second swap time. The psychological dimension of the MG42's effectiveness becomes clearer as the war progresses. Post-battle interviews with Allied soldiers consistently describe German positions as heavily defended by machine guns, even when intelligence later confirms only 1 or 2 MG42s were present. The sustained high rate of fire creates an illusion of multiple weapons, making defenders seem more numerous than they actually are. This force multiplication effect matters enormously in the late war period when Germany faces overwhelming numerical disadvantages. A single well-positioned MG42 with adequate ammunition and spare barrels can hold off forces 10 times larger, at least temporarily. The Eastern Front sees numerous examples of small German units inflicting disproportionate casualties through MG42 positions, delaying Soviet advances for hours or days beyond what their numbers should allow. May 1945. The war ends, and Allied forces capture German ammunition factories, still producing MG42s on assembly lines. American technical intelligence teams document the manufacturing process and discover another aspect of Maier's genius. The barrel system is designed for mass production. The locking collar is a simple turned part that requires only basic lathe work. The receiver modifications are minimal, 3 locking recesses that any milling machine can cut. The spring-loaded catch uses standard components available from any hardware supplier. The entire barrel change system adds maybe 30 minutes to the weapon's assembly time, which in 1940s manufacturing terms is negligible. Compare this to American attempts at quick-change systems that require precision machining, hand-fitted parts, and specialized assembly procedures. Maier designed for the reality of wartime production, millions of weapons built by semi-skilled workers in factories that might be bombed tomorrow. Elegant simplicity wins over complex precision. The post-war legacy of Maier's barrel system reshapes machine gun design worldwide. By 1960, virtually every modern general-purpose machine gun uses quick-change barrels. The American M60, the Soviet PK, the Belgian AAG, the German MG3, a direct descendant of the MG42, all feature barrel change systems inspired by Maier's work. The U.S. military's adoption of the M60 in 1957 represents explicit recognition that the Germans got it right. The M60's barrel changes in under 10 seconds without tools, finally matching, though not exceeding the capability Maier designed. The doctrine shifts accordingly. Sustained fire is limited by ammunition supply, not barrel life. Modern conflict zones from Vietnam to Afghanistan demonstrate the continued relevance of quick-change barrels. American machine gun crews in Iraq carry spare barrels as standard equipment and drill on rapid changes until they can swap barrels while taking fire. The tactical advantage Maier created in 1937, the ability to sustain fire indefinitely, remains fundamental to infantry combat nearly a century later. The German military still uses the MG3, a modernized MG42 rechambered for 7.62 NATO instead of 8mm Mauser. The barrel change mechanism is identical to Maier's original design. The weapon entered service in 1968 and remains the Bundeswehr's standard machine gun in 20. That's 88 years of continuous service for a design created before World War II. Several nations license-produce the MG3, including Italy, Spain, Pakistan, and Turkey. Total production across all variants exceeds 1 million weapons. The barrel change system Maier designed has been manufactured over 1 million times and remains in frontline military service on 6 continents. The evolutionary impact extends beyond direct copies. When weapons designers create new machine guns, they start with the assumption that quick-change barrels are mandatory. The feature Maier invented as a solution to a specific problem, how to sustain 1,200 rounds per minute, has become the baseline requirement for any modern machine gun design. In 2018, the U.S. Army began fielding the M250 automatic rifle, replacing the M249 SOA that had served since 19. Among its features, a quick-change barrel system, that allows swaps in under 10 seconds. The requirement appears in the technical specifications as if it's obvious, with no mention that this capability was considered impossible by most ordnance experts in 19. Karl Maier died in 1974, largely unknown outside small circles of weapons collectors and military historians. No major obituaries marked his passing. His personnel file at Mauserwerke, now archived in German military museums, contains performance reviews describing him as difficult and unconventional, the same characteristics that allowed him to solve a problem everyone else thought was impossible. The final irony: Maier's barrel system was so simple that it seems obvious in retrospect. Why wouldn't you design a machine gun with quick-change barrels? How else would you sustain high fire rates? But obvious solutions only seem obvious after someone has the courage to ignore conventional wisdom and redesign from first principles. Allied soldiers facing MG42 fire in 1944 weren't thinking about the elegance of the engineering. They were thinking about survival while that terrible buzzsaw sound tore up the air around them. But the reason they faced that specific threat, the reason German machine gun positions could sustain fire that should have been physically impossible, traces back to one obstinate machinist who refused to accept that barrels had to stay in the gun. Every modern machine gun carries that legacy. Every quick-change barrel system, from the M60 to the latest designs entering service today, descends from Maier's work at Mauserwerke in the late 19th. The forbidden trick wasn't forbidden at all. It just required someone willing to question why things had always been done a certain way, and brave enough to prove there was a better answer. 5 seconds. That's all it took to change military history.